In this video, we will discuss about sliding puzzle. On a 2x3 board, there are 5 tiles labeled from 1 to 5 and an empty square represented by 0. A move consists of choosing 0 and a 4 directionally adjacent number and swapping it. The state of the board is solved if and only if the board is 1, 2, 3, 4, 5, 0. Given the puzzle board, return the least number of moves required so that the state of the board is solved. If it is impossible for the state of the board to be solved, return -1. So what they are saying is that in the input, we are given a 2x3 board, right? And this 2x3 board has numbers from 1 to 5, and then there is one cell which is empty and which is denoted by 0. So basically, this 2x3 board will always have the numbers 0, 1, 2, 3, 4, 5, right? So in the first example, the board is 1, 2, 3, 4, 0, 5, right? Now what we need to do is that we need to convert this board into 1, 2, 3, 4, 5, 0. This is the final state of our board. Okay. Now in one move, we can swap this 0 with any of the elements in the top, in the left, in the right, or in the bottom. Meaning for this 0, top element is 2, left element is 4, right element is 5, and at the bottom we don't have anything. So this 0 can be swapped with these 3, right? So in one move, we can swap this 0 with any of the element in the 4 directions, right? And eventually, we need to convert this state of the board into the final state. Then, for this conversion, how many minimum number of moves are required that you need to return as your answer, right? So in this case, if you see, for 0, we can swap it with 2, 4 or 5, right? So what will happen? When you will swap 0 with 2, then it will become 1, 0, 3, 4, 2, 5, right? Is this equal to the final state? No. So let's swap 0 with 4. Then what will happen? It will become 1, 2, 3, 0, 4, 5. Is this equal to the final state? No. So let's swap 0 with 5. So it will be 1, 2, 3, 4, 5, 0. Now is this equals to the final state? Yes, it is. So then that means we had to do one move. We had to do one move which was swapping this 0 with this 5, and we were able to convert the board state into the final state. So our answer is going to be 1 in this particular case, right? Now if we take another example, the third example which is given to us in the sample test cases. So it is 4, 1, 2, 5, 0, 3. This is what is given to us. And if I write the indexes, so it will be 0, 1, 2, 3, 4, 5. Right. Now let's quickly try to identify the answer for this particular case. So this 0 can be swapped with 1, 5 and 3, right? So we will have 3 scenarios when we are swapping 0 with the top element, right? That is 1. So we will get 4, 0, 2, 5, 1, 3, right? Then if we swap it with the left element, then we will get 4, 1, 2, 0, 5, 3. And if we swap it with the right element, then we will get 4, 1, 2 and 5, 3, 0. Right? This is what you get. Now, this is the first move that you have done. One move you have done. Right? Now, here if you see, this 0 can be swapped with 4, 2 and 1. Right? But if you notice that when you will swap this 0 with this one, what you will get? 4, 1, 2, 5, 0, 3, which is nothing but the initial state only. Right? So, there is no point of swapping this 0 with this one again, because that particular board state we have already considered here. And if after coming here we will go back again there, then we will be stuck in an infinite loop, right? So that is why, since that particular board state has already been considered, or we can say has already been visited in terms of graph, so we won't be swapping this 0 with 1 again. We will swap it only with 4 and 2, right? So when swapping with left and right, what you will get? So in the case of left, you will get 0, 4, 2, 5, 1, 3. In the case of right, you will get 4, 2, 0, 5, 1, 3. Right? Then here if you see, 0 can be swapped with 4 and 5. Right? But if you will swap it with 5, again you will get this state only. So then that means we can swap it only with 4, which is the top. Right? So you will get 0, 1, 2, 4, 5, 3. Right? And then if you see in this case, 0 can be swapped with 2 or 3, but if we will swap with 3, then again we will get this. So we will only swap it with 2. So again, the top element, so we'll get 4, 1, 0, 5, 3, 2. Right? Now here also there was no state which was matching with the final state. So we will again move forward, right? And this was second move. We have already done 2 moves, right? So let's move next. Now from here we can swap 0 with 4 and 5. But with 4 we have already done here. So we will swap it only with 5. So that is down. So we will get 5, 4, 2, 0, 1, 3. Right? Then here also we can swap 0 with 3 only down. So we will get 4, 2, 3, 5, 1, 0. Right? Then here we can swap 0 only with 1. That is right. Right? So we'll get 1, 0, 2, 4, 5, 3. Right? And then here we can swap 0 only with 1. So that is left. So we will get 4, 0, 1, 5, 3, 2. Now till here we have done 3 number of moves and still we have not reached the final state. Right? So let's move again further. Now here 0 can be swapped with 5 and 1. But if we will do it with 5, then again we will get the same result. So we will do it only with 1. Right? So it will be right. Right? So we will get 5, 4, 2, 1, 0, 3. Then in this case, we can swap 0 with 1. Right? So we'll get 4, 2, 3, 5, 0, 1. Then in this case, we will get 1, 2, 0, 4, 5, 3 after swapping 0 and 2. And another scenario. So see here, 0 could be swapped with 1, 2 and 5. Right? With 1, we had already done previously. So with 2 and 5, we can swap. Right? So with 2, we got this. And with 5, we will get 1, 5, 2, 4, 0, 3. Right? And then similarly, you can find for this one also. So this will give you 4 number of moves. Now when you will come to the next move, you will see that here when you will swap this 0 with this 3, you will get 1, 2, 3, 4, 5, 0, which is the final state. And it was move number 5. Right? So at this point, our state of the board has become equal to the final state and our number of moves are 5. So in this particular case, our answer will be 5. Right? So if we see here what we have done, we have checked all the possibilities. Right? We have checked all the possibilities of swapping 0 with the possible cells. Right? And first we considered all the scenarios where 0 could be swapped with the number of moves as 1. Then we considered all the board states when the number of moves were 2. So don't you think that we are kind of doing a BFS over here? That first we are checking all the board states at move number 1. At the first move, 0 could be swapped with 1, 5 and 3. And we are checking all those 3 scenarios. And then we are moving forward based on these scenarios. Right? So we are doing a breadth first search here and we are identifying the number of moves. Now another thing to notice here is that particular board state which we have already considered, that we are not considering again. Right? Meaning if a board state is already visited, there is no need of visiting that board state again. Right? And the third thing is that whenever we are getting our board state equals to the final state, then at that point, whatever is the number of moves that we are getting, we are saying this is our answer. But you might say that in the question we were asked to minimize the number of moves. So why are we not taking minimum everywhere? Because we have already considered 1, 2, 3, 4, and in all these 4 cases, we were not able to get the final board state. That is why at whichever point you get your board state equal to the final state, at that point itself, you can consider the number of moves as your answer. Right? So now, breadth first search is okay, but how are we going to mark a particular board state as visited? Right? Because our board state is what? Our board state is a 2D vector or array of size 2 cross 3. How are we going to mark it? In a normal graph, we usually have a node, right? Or a value of that node if the values are distinct. So we mark it with the help of that. But here we have a 2D vector. So how are we going to mark it? So we can think of something else. We can think of converting this 2 cross 3 board into some form so that our life becomes easier to mark a particular board state as visited. Right? So what we can do is we can convert this board state into a string. So when we will convert this board state to a string, then it will become 412503, right? This will be our string. So this is the state of the board initially, right? And what will be the indexes here? It will be 0, 1, 2, 3, 4, 5, right? And the final state of the board, this final state, that also we can keep as a string so that we can directly compare our current state with the final state, right? So the final state also we can keep it like 1, 2, 3, 4, 5, 0, right? Now, if you are maintaining the state of your board as a string, then how are you going to identify that this 0 should be swapped with which element, right? So see, when it was a matrix, we knew that when 0 is present at this particular cell, then it can be swapped with either 1, 5 or 3, right? When this 0 was present at this particular cell, then we could swap it with 4, 2 and 1, right? All of these are some indexes, right? So see, here we are having 0, 1, 2, 3, 4, 5 as indexes. Similar way I have put here also 0, 1, 2, 3, 4, 5. And since our size of the board is static, it is always 2 cross 3 board, right? So then that means the position of 0 within this string or in this matrix will lie from 0 to 5 only, right? Now, for each index, can't I store it beforehand that whenever 0 is at a particular index, then with what all indexes can this 0 be swapped? Meaning, when my 0 is present at the index 0, then it can be swapped with either index 1 or index 3. When it is present at index 1, it can be swapped with either index 0, 2 or 4, right? So, what if I store this information beforehand? Meaning I'm saying I will store a vector of vector maybe, right? So where the index of the vector will tell me the index of 0, right? So basically what I am saying is that when my 0 is present at index 0, at that time I can swap it with index 1 or 3, right? Then when my 0 is present at index 1, at that time I can swap it with index 0, 2 or 4. Similarly, when at 2, I can swap it with 1 and 5. When at 3, I can swap it with 0 or 4. When at 4, I can swap it with 1, 3 and 5. And when at 5, I can swap it with 2 and 4, right? So this information you can store beforehand, right? And since we are applying breadth first search here, so what are you going to do? You will be going to maintain a queue, right? Because you have to apply breadth first search. So in the queue, initially you will push the initial state of the board, which is this. So basically, whatever is the board state given to you in your input, you will convert it to a string, you will push it into the queue, and you will also mark it as visited, right? So basically, you can maintain a set or a map, and there you can mark this particular string as visited. So when you will come at this point, right, and you will try to swap this 0 with this one again, so the string that you will get will be 412503, and you will check that this particular string is already present in your map or your set. So you will know that it is already visited and we should not continue with this state, right? And then once you have identified that, okay, this particular cell is not visited, then you can compare it with the final, right? And also how you will identify that with a particular 0, with which indexes should I swap it with from this particular vector. So basically, in your current string, you can identify that what is the index of 0. So here the index of 0 is 4. So you will go into this map. You will check that at index 4, what all indexes we are having. So we are having 1, 3 and 5, right? So then that means we will try swapping this 0 with index 1, 3 and 5. And after swapping, we will check if it is already visited, then we will leave it there itself, we will continue. And if it is not visited, then we will compare it with final. And also, whenever we have considered a particular string, we will mark it as visited and we will also push it inside our queue, right? So this is what our approach is going to be. Now here, how are we able to apply breadth first search? Because see, we are identifying all the possible scenarios. We are checking all possibilities. right? Since the constraints that are given to us in the questions are very less, right? This is a 2x3 board and we know what all numbers are there present in it. So we can apply breadth first search here and we can check all the possibilities, right? So let's quickly code it out. So first of all, let's create a vector of vector. So this will store our directions, right? So it will be for index 0, we have the indexes as 1 and 3. For index 1, we have the indexes as 0, 2 and 4. For 2, we have 1 and 5. For 3, we have 0 and 4. Then for 4, we have 1, 3 and 5. Then for 5, we have 2 and 4. Right? Now we need a queue for performing breadth first search, right? So this will store a string which denotes the current state of the board. And we need a set for marking a particular board state as visited. So that is also a string, right? We can say it as visited, right? Then we need an integer variable moves which will count the number of moves, and then we need our strings. So there will be two strings. One is the final string which we can denote with answer. So this will going to be 1 2 3 4 5 0, right? And we need a start string which will be initially empty, right? So then we will update this start string with the starting board state, right? So what we will do is we will iterate for each row in the board, right? And then in each row we will get what is the number, right? That number we will convert to a string and we will append it inside the start. So it will be toString num, right? So with this, the initial board state will be converted to a string and stored in start. So once we have done this in our queue, we will push this start and we will also mark it as visited. Visited is a set. So in that we will insert start, right? Now we will start our breadth first search. So for breadth first search, we will run a loop that while our queue is not empty, what do? You take the size of the queue, right? Intent equals to queue dot size, and then you run a loop n times, right? For each of the board state which will be currently present in your queue. So we will run a for loop of I starting from 0, it will go to less than n and I plus plus, right? Now inside this, what you will do? You will take the front element of the queue, right? So that will give you a string. This string is the current board state that we are considering, right? So this will be equals to queue dot front, and then we can also pop this string out from the queue. So we will do queue dot pop, right? Now that we have done this, first we need to check that is this current equals to our final string or not. If it is, then moves is our answer. If current is equals to answer, then return moves from here itself, right? Don't go further. Otherwise what we are going to do, we will try to swap 0 with all the possibilities and then we will check every string accordingly, right? So for that, first we need to identify that what is the index of 0 in the current string, right? So let's say int idx equals to current string dot find index of 0, right? So this will give you the index of 0. Now in our directions vector, we will go at that particular index and we will get that particular vector, right? So what we will do is we will iterate, right? So let's suppose in text in directions of idx, right? So basically this will give you all the directions for this particular index, right? And then you will swap. Now what all indexes are you going to swap? This x and the current index of 0, right? So first let's take the current string into some other string s, and then in s we will swap the index x and the index idx, right? After swapping, we need to check that whether this particular string is already visited or not. So if in our visited set, so visited dot find s is equals to visited dot end, then that means this particular board state is being visited for the first time, right? So in this case, in your queue, you will push this particular board state and you will mark it as visited. So in visited, you will insert S, right? Now, once you are done with this particular loop, meaning once you are done for this particular level, so you need to increase your number of moves by 1, right? And at the end, what will happen? When in any of the case we didn't get a string equal to our final string, then that means it is not possible to convert our board state into the final string, right? So that is why at the end we will return a -1, right? So let's quickly run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.